My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 506. In this lecture, we will try to understand EDA follower and following statistics. Before discussing about this lecture, I would like to show you IPython notebook. I already kept this particular IPython notebook in my previous lecture description section as well as in comment section. I request all of you to go through this IPython notebook. Just say this is social network graph link prediction Facebook challenge. We explained about data overview. What is the data? How many columns are there? This is mapping the problem into supervised learning problem. This I discussed. And business objectives and constraints. We discussed this business objectives and constraints. Performance metrics for supervised learning I discussed. This libraries I discussed a little bit about these libraries, and we also discussed what is the type of the graph, digraph, number of nodes, number of edges, average in degree, average out degree, these things. This graph also I have shown in my last class. Now, exploratory data analysis, EDA, that is G dot nodes, the number of unique persons, it says 186,220, the number of followers for each person. I request all of you to go through this particular IPython notebook where you can see number of followers on y-axis and index on x-axis. Even just I would like to show this IPython notebook. This is box plot and this is for there is a in detailed analysis about in degrees and out degrees and PDFs, probability density functions, following relations and number of people sorry, each person sorry, number of people each person is following. Just we have in-depth analysis. We have following, we have analysis and graphs for followers as well as following, isn't it? You have in degree analysis as well as out degree analysis. This is in degree analysis, isn't it? You have box plots, everything. Just say again PDF and also we discussed about in degrees and out degrees, both followers and following. Initially what we did, followers analysis, following analysis, and here we are doing both followers and following analysis. Just say this IPython notebook, as I told you, I kept in description section of my last video or my previous lecture. Even in comment section also we kept this particular IPython notebook. I request all of you to go through this IPython notebook link. Anyway, I will provide same link in this particular lecture description section as well as comment section. Just see this one. Just let me. So now let's understand simple exploratory data analysis. Since we understood network X in my previous lecture, we discussed about network X and some basic statistics about the data, isn't it? So the number of unique people or points in whole network is I can say 18. Just see here, you have that statistics here. What is number of unique people? Just let me show it. Yes, 1 second. Just see. This is G dot nodes, len of G dot nodes. Therefore, the number of unique people or persons in whole network is 186,222,220. That is 1.86 million. So these are the number of nodes, and you can obtain number of nodes as G dot nodes because G is the graph. G is the network X object in which you have stored whole graph. If you just say G dot nodes, it will give all the nodes and the length of that. Len of G dot nodes means what? You will get length of that. You just tell me how many vertices or how many nodes, how many people are there in graph. So the first thing that we that we want to understand is how many followers are there for each. How many followers are there for each person? So let's take U1 as user 1. Let me assume my u1 as user 1, u1 is user 1, u2 as user 2, and u3 is user 3. We want to know how many followers are there for ui. Suppose if I have a vertex ui, followers are those people. Let's say u1 is following ui. Let's say u1 is following ui. Isn't it? If you think about Instagram and Twitter, anything UI updates, that will be available for u1. Isn't it? So if you have an edge like u1 goes to ui, we will call this edge as if u1 is following ui. Isn't it? u1 is following ui. So now we will observe how many followers are there. So the number of followers is exactly equal to in degree. Isn't it? Suppose I have vertex ui, my in degree is, what is this in degree of this particular vertex? This particular vertex in degree is 3. Isn't it? Number of followers. Isn't it? In degree analysis means number of followers, which means that there are 3 other users who are following ui. What do? I just I say g dot in degree dot values. Isn't it? Just see, this is g dot in degree dot values, which tells me each vertex basically it's a dictionary. DICT means what? It's a dictionary, isn't it? It's a dictionary. Yes, I converted a dictionary and I say dot value. So this is now gives me list. I get list of all in degrees for all the vertices which I am sorting now. Isn't it? Just let me sort now. In degree underscore dist sort. In these in degrees, I just sort and the plot that I want to obtain is very simple. Since I sorted it, what this says is there is one user here who just who has just 0 followers. Just see here, 0 followers, isn't it? There I can say what it says. There is one user. There is one user here who has 0 followers. There are many users with I can say there are many users with 0 followers, isn't it? So there are small users more than 0 followers. Just see, more than 0 followers, isn't it? So there are some users more than 0 followers, but you notice that there is a sharp line here, isn't it? Which shows that there is at least one user who have more than 500 followers, isn't it? 500 followers in the data set that is given. But look at how steep this is, which means most of the users have few followers, because look at this, the number, this number is below 40, isn't it? Just it is it's just like less than 40 followers. There is a very small subset of users who have more than 40 followers. So this plot is basically every user is a point. On x-axis you are keeping users. Every user is a point here. So this is index of user. On x-axis we are keeping index of the user. Every user is here on x-axis. Every user is on x-axis, isn't it? And the height here represents number of followers. On y-axis you are keeping number of followers. For that user, something that you notice is most of the users have very few followers, that is less than 40 followers. As I told you, I kept this IPython notebook in description section and comment section. I request all of you to go through that IPython notebook. How can I say, most of the users have very few followers, less than 40, but there is a small subset of users who have many followers, and there is at least one user. There is at least one user. There is at least one user who has over 500 followers, isn't it? That's what this plot represents. Now let's zoom into this plot, because this plot is there from from 0 to let me zoom this particular plot. If I zoom this, look at this here. I have 0 to 1.86 millions. I think that's the total number of users. If I go from 0th user to 1.86 million user, I'm zooming this in between 0th user to 1.4 million users. Even here there is a huge variation. Let's look at this plot. So these many users here, these many users here who have just 0 followers. There are some users, all these users have one follower, all these users have one follower, isn't one follower. These many users has exactly one follower. You can't have 1.5 followers, isn't it? You can't have 0.5 followers. These many users have 2 followers, isn't it? These many users have I can say these many users have 3 followers, so on and so forth, isn't it? Even this curve, if you smooth this curve, even this smoother curve is fairly steep curve, but you get a sense, almost 1.4 million users, that we have less than or equal to 7 followers. So now the tricky part is, if you plot your box plot, almost it is impossible to read it. Your mean, median, all are small. There are bunch of outliers here where there are some users have lots of followers, isn't it? Just see, you can see bunch of outliers. They have many followers. There is a there are a bunch of outliers here. These are the outliers, isn't it? Here where there are some users have lots of followers, most of the people don't have those many followers. So now let's look at the 90 to 100 percentile. So if I sort all of my in degree, all of my follower numbers, 90% of users have less than 12 followers. 99% of users have less than 40 or fewer followers. 99% of all of my 1.86 million people or users have less than 40 followers or fewer followers. The 100 percentile, there is a one user with 552 followers, isn't it? This is from the 90th to 100 percentile. If you zoom it to this from 99, from 99 to 100 percentile, summary here is 99% of the people having 40 40 or fewer followers. If you zoom this in, even 99.9, isn't it? 99.9 people on this social network have 112 followers. Just see, 99.9 percentile values have 112 or fewer users. There is only 0.1 percentile of users who have more than 112 followers, which is most people have very few number of followers. That's the key takeaway. Of course, you can plot PDF of it. You can plot PDF of it. This is a PDF of it. Obviously, we see that most users have very small number of followers. This is like peak distribution. Green line is the histogram. That is green bar plot. Green bar plot is the histogram. This is smoothed curve. Which one is smoothed curve? This one is smoothed curve, isn't it? This is smoothed out of PDF. Similarly, just like this, you can also compute number of people each person is following. Till now, what did we do? Given a user, we said how many followers are there, isn't it? The other way of looking at this graph is given a user, how many is he or she following, isn't it? Which is the out degree, isn't it? Till now we discussed about in degree, which is the out degree. So till now we have done the in degree analysis. Till now what we did in degree analysis. Till now we did in degree analysis. In similar manner, you can perform out degree out degree analysis, isn't it? Let's do out degree analysis, exactly the same analysis, except that you will write, in the case of out degree analysis, what you have to write, G dot out underscore degree. As I told you, I already kept this particular IPython notebook in my previous lecture description section and comment section. Please go through that IPython notebook, isn't it? G dot out degree, except this code is exactly same, and most of the analysis is just the same. So what we understand here is, since there is out degree, the number of people each person is following, there is one, just now you have to just do out degree analysis, the number of people each person is following, isn't it? Again, we will say same graph and just the same thing, box plots and everything, and 90 to 100 percentile analysis. I request all of you to go through this. Even in IPython notebook, I discussed about there is a code for in degree as well as out degree. What we did, we analyzed in degree analysis. Just to understand in degree analysis, out degree analysis, out degree analysis. What is the sum of in degree and out degree analysis? Sum of in degree and out degree analysis. Out degree analysis. This lecture may not allow me to spend more time. Just check, as I told you, just check this particular IPython notebook and go through that IPython notebook. Everything is explained in detailed manner in IPython notebook. If you have any difficulty in understanding IPython notebook, which I kept in comment section and description section of my previous lecture, just keep a comment so that we will try to understand. Thank you very much.